Hello, math enthusiasts. Welcome to Invalid Proof, the channel where we dive deep into the fascinating world of mathematics. And today we are here with a geometry question that will be part of a series for GRE exam preparation. We have a square here, we have two quarter circles, a rhombus, and we are going to calculate the area of this rhombus. Let's go. All right. So what we have here is a square which its side is equal to 1. So we have 1 here, here, and here. There's ACE, which you can see here. It's a it's an arc of a circle with the center with the as D. And this, we have the same thing on the other side, AFC, which is here, and the center of that circle would be here at B. What we are going to calculate is the area if of this rhombus AECF. This is what the question has given us, and we are going to see what we can do with this. I recommend you to pause the video and try to solve it by yourself, and then come back to the video and see what you if you did correctly or if you made a mistake or something, and try to just learn something. All right, let's go to the solution. So what we want here is the area of this rhombus AECF. But how do we calculate the area of rhombus? It's half of the product of its diagonals, right? So what we need is to find the length of its diagonals. One of the diagonals is AC. Oops, what a line, right? So what we want is AC, and also what we need is to find EF. Okay, so finding AC is actually pretty easy because it's the diagonal of this square, and we have the side of the square, and we can easily calculate it with any way that we know. The one of the ways that you can use is the Pythagoras theorem, which is quite easy, but also there is a way to calculate this diagonal of a square a lot faster, and you will need this in exams like GRE because you need to manage your time. So I'm gonna show you how I would do it. So because the side of the circle is 1, the diagonal would be a square root of 2. But how? Let's see. So anytime that we have a circle with whatever the side is, it doesn't really matter. And we want to calculate the diagonal, right? Just think about this as a straight line, okay? I'm drawing on a drawing tablet and sometimes it's not perfect. So let's say this is x. We want to apply the Pythagoras theorem on this. So it would be a squared plus a squared equals to x squared. And it gives us 2 times a squared equals to x squared. And now we do something like this, and we will have. All right, so now the square root of x to the power of 2 would be absolute value of x, but since x is a positive number because it's the length of something, it would be absolute value of it would be equal to its original value, and the same thing applies here. So it would be square root of 2 times square root of a squared, and we will have this. And then again, the same logic applies to a. A is a positive number, so its absolute value is equals to itself. So we will have a times square root of 2 equals to x. So whenever you had a circle and you knew the length of its side, to calculate the diagonal, you only need to multiply the side by a square root of 2 and you will get the diagonal. And here in this question, the side of the square is 1, so the diagonal would be 1 times square root of 2, which gives us again square root of 2. Now, let's get back to our question. So now we know AC is square root of 2. Now we want to calculate EF, right? This is the challenging part. How are we going to do this? Let's see. All right, so we have, I kind of rotated a little bit to make it easier to see. Let's take a look at BD, right? First of all, BD is the diagonal of a square, so BD itself is equals to square root of 2. On the other hand, let's take a look at these smaller segments, right? So we have BF, right? What is BF? BF is the radius of this quarter circle, and it equals to side of our square, which is 1, right? And the same logic applies to ED. So now what we have here, I wanna just write it down. So let's say this is our BD. Okay, I wanna do it like this. Okay, let's say this is BD and this equals to square root of 2. On the other hand, what we have is this as, sorry, as, let's say, BF, and here we have ED. All right. So this equals to 1 and this equals to 1 again. Now, let's see what we can do. Let me just change the color. All right. So let's say we have this part. I want to separate them. Let's say this is x, this is y, and this is y again because they're equal. And this would be z. Now, from this one, from the number 1, well, there's no, we can just do the same thing, right? I want to just separate it. So this would be x, this would be y, and this would be z. These are the same points like E and F. So from the first one, we have x plus y plus z equals to square root of 2. And from the second one, we have x plus y, which is BF, plus y plus z, which is ED, equals to 1 plus 1, first grade, equals to 2. This would be our BF, and this would be our ED. All right. Now, what we can do to calculate what we need is just simple, right? We say the second one minus the first one. What it gives us is that if we want to do this, this x would go away with this one, this y with this one, and this z with this z. And we're left with one y, and it equals to, right, 2 minus the square root of 2. Simple, right? But we're not finished yet. So y is basically EF. We have here, right? Y is EF. And we just calculated the other diagonal of this rhombus that we needed. And now we need to calculate the area. So uh, we have, let me see. All right. So we calculate this and we calculated this one. 2 minus square root of 2. Now what we want to calculate is the area, which is half of product of these two. Square root of 2 times 2 minus square root of 2. Now, there are many ways to calculate this. You can just do this easily. However, uh, in tests like GRE, you want to do them as fast as possible for any test, a kind of exam. And in order to do that, there are different ways to do that. And I want to show you how I would calculate this mostly in my mind without needing anything to write. So what we want to calculate is this, right? But one easy way to do this is to first of all calculate this. How? Very simple. So I do something like this. This 2 in the bottom, I would write it down as square root of 2 times square root of 2. And we have also this square root of 2 at the top. And we can just simplify it like this. This square root of 2 goes with this square root of 2, and we're left with 1 divided by square root of 2. So this whole thing goes away. And now we're left with this. This square root of 2 goes to the bottom here and here. And we can use the same logic to simplify this one. And then again, I'm just writing this down to show you how I would do it in my mind. You won't need to write this down when you are calculating this. With practice, you can just simply do this in your mind. So just separate this division like this, square root of 2 and square root of 2. And then again, we use the same logic that we used before for this one. And so square root of 2 times square root of 2 on square root of 2. With simplification, we're left with the square root of 2 for the first part. And this just goes away, and this would be minus 1. And this is the final answer. If you like this video and you found it helpful, please like and subscribe and share it with your friends. And finally, thanks for watching and catch you in the next one.